So Dr. Cottam gave us a problem. You may not see it as a problem, but he had a series of questions. I'm going to lay out his questions at the end of all this, just so we can think about it. And if you want to work with him, he was very keen on having cadets work with him. But for me, I would like to first think about everything as simple as possible with numbers. So I'm going to fill in a table. And the way I'm going to choose to fill in this table is I'm going to start tracking the number of patients that attend a clinical visit. And the reason for that is that's just the way my mind was thinking. You heard me talking to him and I asked him, so you're expecting that the number of patients that are going to come visit by visit is going to be 70% of the previous. I'm just going to play with some numbers first to kind of see how that would work. And I'm going to start with something easy because I'm going to have to take 70% of something. So I want it to look nice. So at clinic visit 0, that's the surgery, everybody attends. And I'm going to call that 100 people just to start off with, just so my numbers work out easy. Remember, I'm just trying this with numbers to see what it looks like. So that's the initial visit. And the first visit, according to Dr. Cottam, the organization, the American Society for Bariatric and Metabolic Surgeons, ASMBS, Metabolic and Bariatric Surgeons, wanted to see everybody sustain 70% of their population coming back for clinic visit number 1. And what that is they're coming back after having the surgery. So it's supposed to decrease by 70%, or be a 70% of the original. So if I have 100, initially I would have 0.70 times 100, which is 70. And remember, I asked him that several times, like, this is what you expect to see, or you would want to see. Similarly, I asked him another question, like, if you saw this many at visit 1, you would see a 70% of that returning. And so he said yes. So to get to the next clinic visit, what ASMBS wants is they want 70% of the previous population to return. And so I get 0.7 times 70. I would expect to see 49 if I'm adhering to ASMBS guidelines. And I got that by multiplying the previous number by 0.7. I can continue this. I can say, okay, 49 patients showed up in clinic visit number 2. Then I could look at clinic visit number 3 and ask 70% of them to hope that 70% of them are going to return. And I get 34.3, which there's no 34.3 patient. So I would think that something like 34 would be the right number of patients that I expect to see in the 3rd clinical visit. And I can keep doing this. I can tell you by doing this continuously down the line, I could tell you how many patients I would expect to see at the 10th clinical visit, for example, under this. Put those numbers neatly. I explained how I got them, and I did that so I could understand. So I don't think letters first, I think numbers first. Once I get the numbers, I start thinking about how I'm going to generalize them to letters, and there's a reason why. I want to take this real-world problem, understand it with numbers, and then transform it to a model which has variables and letters in it, so that I have something sophisticated that I can use to program, for example, and give all kinds of information back to Dr. Cottam. First of all, anything that varies in my table is called a variable. And you see that the 0, 1, 2, 3, that's varying. That's a clinic visit. So I'm going to tag a letter to represent that symbol of these clinic visits changing. So n equals 0 would be the surgery itself. That's the 0th clinical visit. N equals 1 would represent the 1st clinical visit. Now if I say n equals 10, because of the way I've defined this, you know I'm talking about the 10th clinical visit. On this side, we use some notation that you may not be familiar with. It's a P sub n. Sub means that it's subscripted by n. And so there's two things going on here. This table on this side, the right side, is number of patients. But it's number of patients that attended clinical visit n. So this subscript n reminds me that I'm really looking at the number of patients that attended a particular clinical visit. So for example, P sub 0 is a number of patients that attended the 0th clinical visit, which is the surgery. P sub 1 would be the number of patients that attended the first clinical visit, which is 70. P sub 2 is the number of patients that attended the second clinical visit, and so forth. This particular P sub 0 is special. It's called an initial condition. And in most situations, we know what that initial condition is. So I made up 100 just to kind of play around with the numbers. But if I really wanted to know P sub 0, all I have to do is go ask Dr. Cottam, let's take a month, let's say month of May, and ask him how many patients had a surgery in the month of May. And he would give me that number. And so that in most situations, we know what that is. I also can tell you how to go from one letter to the other. So P sub 1 is 0.70 times P sub 0. That's how I got these numbers in the first place. P sub 2 is 0.70 times P sub 1. That's how I got those numbers. And so forth. Now, do you see a pattern? You notice that these formulas all kind of look the same. The 0.70 is the same for all of them. And I always have the new is 0.7 times the old. So I can write that down generally now with just n's and p's. P sub n is equal to 0.70 times P sub n minus 1. That's my model. I have now transformed Dr. Cottam's description into a model. With initial condition that I made up here, P sub 0 is equal to 100. This model, this relation between the previous and the next, or if you want to say the present and the past, however you want to say it, is called a recursion equation. That idea that I'm actually looking back and going to the next one. We also call it a discrete dynamical system, a DDS. That's West Point three-letter acronym lingo. And that is because it's the same concept as going to your calculator and pushing the same button over and over. You're actually doing something we call iterate. And that iteration comes from a whole discipline called dynamical systems. In this case, discrete dynamical systems. I'm not going to get into that too much. You'll hear those words a lot. But this is the mode of how we're going to model things here in this class, at least for the first chunk.